So next thing I want to do is give you a demonstration of some of the forces that you can use to drive the animation, so to drive the simulation. So the first one I'm going to show you is the pop steer seek, I think it's called. So this is a force which drives the points to a certain location, right, certain position. So one thing you can do is use the original source points, okay, because they have the same points number as the agent. So I've got 37 here and 37 on this. Well, you can't see it now. Yeah, 37 there. This agent will run to this same point, right? So what I'll do, if I grab a transform and just move them over arbitrarily, I'll go the other way, say 30 meters over that way. Okay, so these agents will now run to these points. Maybe I'll do it a bit further. Okay, so let's implement that. I'll just drop an out null for this. Out seek. Let's give that a color. And well, while I'm here, I'll just do another thing I want to do as well. Just drop an obstacle in between them. So I'll drop a box, move that over. This was 50, so you know, in the middle somewhere. 25. Oh, not the size, the center. 20, not up. 25 over that way. Minus 25, and then bump up the scale a bit, 5, let's say. Maybe rotate it on the Y. Okay, and the idea is I want the agents to run around this box to these points. And let's drop another null here and call this out box. Right, so the agents will run from here to there around this box. Hopefully. One more thing actually, which I'll drop in now, which we will use for our final shot, is a curve. So we can use this curve. Let's drop a null here. So if you remember, this was the curve we used to for the direction of the agents. So I'm going to use this to drive the direction, the velocity of the agents, right? So they keep running in circles basically. So I'm going to call this out curve. Okay, give that the same color as well. Great. So let's jump back into our .sim and implement this. Look how simple of a simulation that is. Just 3 nodes and it works. You know, it's kind of a shock when you work with the shelf tools and build the crowd solver, because you just get all these, you know, you get a lot of nodes, but they're not necessary. It's good to know the basics, just what you need, so that when you have problems you can go back to just, you know, just the bare bones of what you need and build up from there to find out where, you know, sometimes when you're having a problem you can't identify where it is. It's useful to know. So let's drop in. So as I said before, they're all called pop. So you can use all the pop forces as well, but the pop steer forces are, you know, made especially for crowds, or have been adapted for crowds. So first we need pop steer seek, I think. Okay, and as I said, we just drop that in between the crowd state and the solver. And all of these have either a pop force or a crowd steer force, and that gives you this idea of weight, which you can also see in the solver. So the avoidance has a weight, the locomotion I think even has a strength though, not a weight. Other things I think. So the weight basically is like a balance. So, you know, at the moment we've got avoidance at 1, a weight of 1, and this at 0.5. So it will favor avoidance over the seek. Okay. So yeah, always set this to crowd steer force. Weight you can play with later to, you know, these are things you need to play around with. The goal will not be a position. We're going to be using points. And the path, so we're going to go ahead and find that source. So out source, no, seek, that's right. And that should be it. Let's try it, see if it works. So they should run over here. Yeah. So you see now that before they were all running out in a circle. Now they're all running over here. And then when they arrive, because they can't change their state, they just start running in circles. Okay, so you could set up a trigger so that when they are within a certain distance of that point, they change to an idle pose, which we don't have, or they turn to a ragdoll, they fall over, or whatever. Okay, so let's try and bring in the box as well. Go back to the start, pop steer obstacle. So this is good for, you know, very commonly you're going to have crowds running around a city with buildings or cars, and you obviously don't want them running through them. So again, crowd steer force, you have a weight there. This is set to 1. That's fine. The source is SUP. We want to find it. It is our box. Turn that on. Guide. I think the guide is just the point scale. So if we go back, just so we can, I'm not sure if we'll, no, we won't be able to see it actually. Let me just try actually. If we visualize the box here, and go in here, turn on the show all objects, but I think if we go in, yeah, we'll lose it in there. It's a bit annoying. But never mind, we should see the effect if we just go out. Let's see. So maybe a little bit, but some of them are not following. So let's take a look at the forces. So the scale will be the scale of the particles themselves. So if we put on the guide, you can see a point at each one. We can push this up to 2. Okay, so this is like the P scale of the agents. Push that up to 5. And then the avoidance forces, so we got a far avoidance force and near avoidance force. So when it's at a certain distance, it will, the velocity will push it away from this box by this much, and when it's below a certain distance, it will use this force. So I'm gonna just push this up to 100, you know, to see what that does. So there, that seems better. Let's take a look. Here we can watch. There we go. So yeah, you can see them all running around the box there. None of them are intersecting. Great, and then they run over to the points. Okay, so as I said, this is just a demonstration, so maybe I'll put this in a box just to highlight it and put demo there. And then we're going to use the same sim for our setup for the main sim. And we're not going to use these. We're just going to use pop, steer, and path, I think is what we need. Yeah. Okay, pop, steer, path. So let's go and find our path. Out curve. Okay, we've got some values there again. Crowd steer force. Where are my agents? I think again this doesn't have a guide. Would be nice to be able to see the curve. Never mind. So let's see. There we go. So without this, they would just they would run away from each other, as you can see, which is also, you know, a cool effect. But with this, they all stay in line and trying to follow this this curve running in a circle. Oops. We'll adjust the values later if we need to. Cool.